Hello children, in this video we shall discuss some important activities. We'll start with activity 2.8. You know that all acids generate hydrogen gas on reacting with metals. This observation shows that hydrogen is commonly present in all acids. But does it mean that any chemical substance or compound which contains hydrogen is capable of showing acidic properties? Let us find out. We'll perform activity 2.8 to understand why all substances which contain hydrogen cannot conduct electricity like the acids do. You need to remember that a chemical substance or a compound which we call an electrolyte can be an acid, a base or a salt. It conducts electricity when it ionizes to produce positively charged cation and negatively charged anion in its molten state or in its aqueous solution. In the beginning of this activity, we need to arrange for an experimental setup as shown in figure 2.3. We fix two iron nails on a cork and place the cork in a 100 ml beaker. Then we connect the nails to the two terminals of a 6-volt battery through a bulb and a switch. We pour about 50 ml of dilute hydrochloric acid in the beaker and switch on the current. We observe that the bulb glows. We repeat the same experiment with 50 ml of dilute sulfuric acid. This time also the bulb glows. The glowing of the bulb indicates that solutions of hydrochloric acid and sulfuric acid conduct electricity. Then we repeat the same experiment with glucose and alcohol solutions. We switch on the current, but the bulb does not glow. This indicates that solutions of glucose and alcohol do not conduct electricity, unlike hydrochloric acid and sulfuric acid solutions. We can explain our observations like this. All acids ionize in aqueous solutions to produce H plus aqueous or hydronium ions and the corresponding negatively charged ions. These ions help conduct electric current through their solutions. For example, if we take hydrochloric acid and sulfuric acid and dissolve these acids in water, we will get hydronium ion and the corresponding negatively charged ion, chloride in case of hydrochloric acid and sulfate in case of sulfuric acid. Substances like alcohol, glucose also contain hydrogen, but they do not form ions in aqueous solutions. Therefore, do not conduct electricity. Like acids, alkalis, which are water-soluble bases, also ionize in aqueous solutions to form ions. For example, alkalis like sodium hydroxide and calcium hydroxide, when dissolved in water, they form ions. The ions are positively charged ions, which are metal ions, and the correspondingly negatively charged ions. In case of sodium hydroxide, you will find sodium ion and hydroxide ion. In case of calcium hydroxide dissolved in water, you will find calcium ion and hydroxide ions. These ions help conduct electric current through the solutions of alkalis. Therefore, alkaline solutions also conduct electricity. Now, we will do activity 2.9, in which we take about 1 gram of solid sodium chloride in a clean dry test tube and set up the apparatus as shown in this figure 2.4. We add concentrated sulfuric acid to the test tube. The reaction which occurs in the test tube is this, in which hydrochloric acid forms vapors. We pass these vapors of hydrochloric acid through the delivery tube and bring dry blue litmus paper near the open end of the delivery tube. We do not observe any color change. Again, we bring a wet blue litmus paper near to the open end of the delivery tube. On doing so, we observe that HCl vapors turn the wet blue litmus red. This shows that dry HCl gas does not show acidic properties, whereas HCl solution shows acidic properties by turning blue litmus paper red. We can explain our observation like this. Acids form H plus aqueous or hydronium ions only in aqueous solutions in the presence of water. So they exhibit acidic character in the wet state when they are mixed with water. The separation of H plus aqueous ion from HCl molecules cannot occur in the absence of water, so dry HCl does not show acidic nature and cannot change the color of dry blue litmus paper. When dry HCl vapors come into contact with wet litmus paper, HCl solution is formed in which H plus aqueous ions are present. Therefore, HCl solution shows acidic nature and turns blue litmus paper red. Now we'll see the next page of your book. Whenever neutralization occurs between an acid and a base, the acid produces H plus aqueous ions and the base produces OH minus ion or hydroxide ion in water. These ions combine together to form a neutral substance, water, and therefore in every neutralization reaction you will get water as a byproduct. Thank you.